This video is going to talk about the process of predicting whether an insoluble salt will be formed when you mix two solutions. And so you already know those are soluble salts. And we're going to write the net ionic equation from that. Okay, so if we have silver nitrate, we have silver ions, He+, and nitrate ions, NO3-. In solution, okay, and that's in one beaker. And in another beaker, we'll have potassium ions and carbonate ions. Okay, now, so we don't need to necessarily write two potassium pluses for every carbonate, but that's indeed true. Okay, so we know that these and these will be in solution together because they're already in solution. We know that these are in solution together too. But the other reason we know this is because of the solubility rules. Now, the solubility rules are something you're not going to have to memorize, but you have to know how to use them. So that's what we're going to do. All right, so if you mix two solutions, then you have to consider, is there any new combination that is not soluble? Okay, so the new combination is potassium ion and nitrate. And so the solubility rules say all group 1A cations or salts are soluble. So potassium salts are soluble, so it doesn't really matter about any rule about nitrate. However, there's a rule for nitrate as well, and it's soluble. And so actually, when you look at all the rules, there is one rule that more or less rules them all, and that is that the soluble salts generally have low charged ions in them. That's because if you have high charged ions, there's a strong force of attraction of the ions in the crystal, and they really don't want to leave. So the other new combination is silver ion and carbonate. Now, silver is one of those cations that's in a lot of the exceptions to the rules, and there's a lot of insoluble silver salts that are for anions which are generally soluble. However, carbonates are generally insoluble as well. So we definitely predict silver carbonate as being precipitated. All right, so now we do need to recognize that we need two silver plus one ions for every carbonate, so we're going to have to write this. We write down as a solid, okay? And then, of course, now to do the net ionic equation, we do need to know all ions. Okay, so the aqueous silver solution, aqueous silver ions and nitrate ions, but we'll need two of them, right? So we need to double up the nitrates and the silvers to balance everything. So two silvers, two nitrates, and two potassiums. Now, I don't quite have room, one carbonate. Okay, now over here we have potassium ions that aren't used, and we have two nitrates that weren't used. Okay, so what we've done is taken an overall reaction, which I've not written for you, but I shall now. So in the balanced chemical equation, in the form you've probably seen before, you say, hey, I just have a silver nitrate aqueous solution, but now I realize it's a soluble salt, it's an electrolyte. Potassium carbonate solution, those potassium ions and carbonate ions. I predict the new combination, which is insoluble. So you put S instead of AQ, and then, of course, the cross for the two nitrates and the two potassiums. All right, so that's what this green equation more or less looks like for the pink equation. All right, so if you do this one first, and then you have to look at each term and decide if it's ions or not. All right, so this is the balanced chemical equation. This is called the total ionic equation because It describes anything that's dissolved as an electrolyte as ions. If it's not dissolved, it's just a solid. Then the net ionic is what you get when you realize potassium plus has not changed. Okay, it's a spectator ion. And nitrate ion has not changed either. And so what's left is called the net ionic equation. So it says that two silver ions, no matter where they came from, and carbonate ion, no matter where it comes from, cannot coexist in a solution at the same time. They will come out as solid silver carbonate. Okay, so the second problem, which I don't have time to do, you do exactly the same sort of thing. You have a lead 2 cation and nitrate, and you have sodium cation and sulfate. It turns out the new combination that is insoluble is lead 2 and sulfate, and so the product is PbSO4. This is one of the plates in your car battery, as a matter of fact. And the net ionic equation after you do everything, it's just saying that sulfate ion and lead 2 ion cannot be simultaneously dissolved in the same solution. They'll precipitate as lead 2 sulfate.